Good afternoon, teenagers. This is Mr. Williams, and I'm making this video for regular physics for 5th and 6th period on Thursday, January 30th, 2020. I asked you last night to do 3 or 4 problems for homework, so it is my expectation that when you come into class today and you sit down and Mr. Knight shows you this video that you will have already done this problem. You should have done 1, 2, and 3 last night. So I'm going to try to help you out a little on these in case you had trouble with them last night. After I'm done with helping you out with this, and I'm going to do it kind of quick, just 1 or 2 of them, you're going to need to finish 4, 5, 6, and 7 here in class today after I'm done talking. And then tonight when you go home, you need to do 8, 9, and 10. So that when I come into class on Friday, that's tomorrow, you should have every single one of these finished. And I should be able to call on you to come up to the front and show your work and explain it. And you should be able to do that. So it is my expectation that you are ready to come up to the front of the class and explain to others what you did. So I hope you're paying attention. I would hate for anyone to be embarrassed. Let's get started with number 1. A 16 kilogram canoe is moving to the right at 4 meters per second. 12 meters per second. So here's a canoe, and its mass is equal to 16 kilograms. And it's moving to the right, and its velocity is equal to 12 meters per second. So this is B4. And I'm going to call this direction positive, and I'm going to call this direction negative. And then it makes an elastic head-on collision with a 4 kilogram raft. So a raft is just going to be like logs, I guess. So here's my raft. And it is moving to the left, so it's moving this way. And it is going at 6 meters per second, but it's going in the left direction, so that's negative 6 meters per second. And its mass is 4 kilograms. After the collision, blah, 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 find the velocity of the canoe. Okay, whatever. We'll deal with that in just a second. I know conservation of momentum, and you should too, because I've spent so much time talking to you about it. Conservation of momentum says that the sum of all momentums initially is equal to the sum of all momentums finally. So I need to figure out what the sum of all momentums initially is. Sum of all momentums initially. So I have 2 objects, so I must have 2 momentums. So it's going to be, if we call this object 1, that'll be m1 v1. And if we call this 2, that'll be m2 v2. My 2 looks very sad, but whatever. So this is going to be P1 plus P2, which is going to be equal to, P1 is going to be M1 V1 plus M2 V2. M1 is 16 kilograms, and V1 is 12 meters per second, plus M2 is 4 kilograms, and V2 is negative 6 meters per second. Let me go get a calculator because I'm too tired to try to do this in my head right now. Oh, Lord. Did one of you kids take my calculator? Check your backpacks. My light blue calculator, I don't see it around here. If one of you took that one, please put it back up in my rack on the wall. That's my favorite one. Okay, we'll use this one, I guess. So 16 times 12 plus 4 times negative 6. Yeah, that's 168. So that is 168 kilograms meters per second. Yeah, check your backpacks in case one of you stuck. You borrowed my calculator and put it in your backpack by accident. So that is the momentum initially. So that's before. And here's after. After what happens? It says it's inelastic, right? See, it's it's elastic. I'm sorry. Problem says it's elastic. So elastic means they bounce. So this is going to bounce. They're just going to bounce off each other. Now, bounce could mean that this one completely stops and that one keeps going. So bounce could be that the raft goes off to the right and the canoe goes off to the left. Or bounce could mean the canoe stops and the raft moves to the right. Or bounce could mean that the canoe bounces off to the left and the raft stops. So there's 3 options. Let's see what we think is going to happen. It says the raft moves. Oh, it says the raft moves to the right. So here's the after picture. Here's my raft, which has somehow gotten larger because I can't draw. And did the raft's mass change? Did it get bigger or smaller because it ran into something? Not unless something fell off of it, and didn't say anything fell off of it, so let's say it didn't. Then the raft is going to have the same mass, so M2 is equal to 4 kilograms. It's going at 20. Boy, that thing is booking. 22.7 meters per second. And it's going in the positive direction. So V2 is going this way at 22.7 meters per second. Holy macaroni. So that canoe either stopped or something. Like, that's a dramatic change. And I guess it still could be going this way, but it would be going really slow. We're going to find out. We don't know. So here's my canoe, and it hasn't lost any mass either. But so its mass 1 is 16 kilograms. Hasn't lost any mass, but we don't know its velocity. So velocity 1 is equal to question mark. So sum of all momentums finally is going to be the momentum 1 I should say initial here, but I don't want to get all crazy. Momentum 1 plus momentum 2. So that's going to be equal to M1V1 plus M2V2. But hold on, conservation of momentum is true. By conservation of momentum, the sum of all momentums initially is equal to the sum of all momentums finally. Therefore, these 3 little dots mean therefore, 168, the final one, sum of all momentums finally, must be equal to 168 kilogram meters per second. Because if the initial was 168, the final has to be 168 too, which means this is 168 right here. The final is 168, and 168 is going to be equal to M1V1 plus M2V2. So I'm just going to put this in a little box just to remind you teenagers that conservation of momentum is still a true thing. So then we got 168 kilogram meter per second is equal to all this junk. M1 V1 plus M2 V2. And I know everything except M1. I don't know this, so I need to isolate it mathematically. So you remember from your algebra class, you can subtract M2 V2 from both sides. So 168 kilogram meter per second minus M2 V2 is equal to M1 V1. Now, I want to get V1 by itself still, but it's multiplied by M1. If two things are multiplied together and I want to break them up, what do I need to do? You should know that. It's divide. So then I divide both sides by M1. Both sides by M1. Some kids screw up and they want to just divide one thing by M1. No, you have to divide the entire side over here by M1. So those cancel out. And this becomes V1 is equal to 168 kilogram meter per second minus M2 V2 all over M1. So let's look at what that means up here. 168 kilogram meter per second minus M2 is 4 kilograms times V2 is 22.7 meters per second all over M1 is 16 kilograms. Now I have to plug all this junk into my calculator. And I'm going to show you how to do it because I know that calculators are somehow incredibly challenging to some of you. So here we go. Hopefully you can see that without a glare. You see I've got this whole junk here in the top. You should put the entire top with the parentheses around it. So I'm going to start out with the parentheses so that everything in the top goes together. I got 168 and minus, and then 4 times 22.7. Close my parentheses. If you don't close the parentheses, your calculator is not very smart and it will mess up. Divided by 16. Well, technically it is not messing up. You would be messing up, but let me just be nice and pretend. So there we go. This is the correct answer. I'm going to show you what would happen if you did not do this right. If you did not put that parentheses in the top, this is what you get. 168 minus 4 times 22.7. This is a lot of kids do. They just hit divide because they didn't put parentheses around the top. And it's 16. And I'm going to tell you why this is wrong. This is wrong because your calculator is following your directions. You told it wanted to take 168 and subtract 4 times 22.7 divided by 16 from it. So the first thing it's going to do is going to say 4 times 22.7 is going to divide that by 16. And then it'll take that number away from 168. That's not what you want. You want the entire top to get divided by 16. So you have to take 4 times 22.7, take that away from 168, and then the answer from that needs to be divided by 16, because that's what we said to do here in this fraction. So if you did it wrong, you would get this, 162.325, and that is just way wrong. That's not even a little bit right. That's completely horribly wrong. So the answer is 4.8. I'm going to round it to 4.8. So this is equal to 4.8 meters per second. Oh, look, that was one of the options I said. So they smack together. This one goes flying off like a bat out of Hades, whoosh, really, really fast at 22.7 meters per second. And this one, which rammed into it, it's still going in the positive direction, but it's just going really slow now because remember up here, it had started out at 12 meters per second, and now it has slowed down to 4.8 meters per second. But why didn't it come to a stop or turn around? It's because it's so massive. This is 4 times more massive than this. So it slowed down, but it was so massive that it takes a lot for it to slow down. This is light, so it's really easy to speed up. Okay, I have done number 1 for you. So if you had trouble getting started last night, hopefully that helps. Now, my expectations for you remain the same. You've got to get through number 7 by the end of this period. So I'm going to turn off this video, and you little munchkins better get to work. Good luck. I'll see you tomorrow.